everybody, hope we're all doing well. Welcome to the channel if you're new, and welcome back if you have been watching for a while. I'm so sorry for the late posting. I know it has been a while, but I've been caught up with a lot of things, such as leaving cert results that came up on the 25th. I got an overall score of 544 out of 600, so that's about 91%. And for chemistry, I got H2. So, thank God for that. Truly, I did think I would have been failing for a lot of subjects, but without God, I wouldn't be standing here talking to you again. I'm not in tears. Even if I do cry, it's only because of happiness. So, this video is not part of the playlist that I've been doing for a good while. This is, as you can see, an introduction to oxidation and reduction. So this topic was suggested by Ash Pure Genius. If I can put up a little picture, I would. Shout out to you. Thank you. You are the first person to ever suggest anything on my channel, so thank you so much. You are a good stepping stone to anybody who is doing these type of things. So again, everybody, I might be doing college stuff and waiting for all the CAO offers, so I do apologize in advance. If I'm not that consistent. I am keeping this channel as self-discipline for me as well. So I won't abandon yous. Sorry, I might be going out of touch in some topics, but don't worry, I will get myself pick it up and then I will help yous with it. So, as the title suggests, it's going to be oxidation and reduction. Oxidation and reduction is also known as redox. And good thing, this is a very timely suggestion because redox is something that I'm going to be doing in the next section of the titrations. So if you don't know the basics of redox, you wouldn't be able to do that titration that well. Unless you have watched my intro to beginners titration, you would be able to do it, but you wouldn't catch the concepts that well. So to a person who may not know chemistry that well or just has a basic point of view of chemistry, I would just simply explain redox as the transfer of electrons. Now, why is that? Well, it's all about if a compound is losing electrons or gaining electrons. So I'm going to give you an example of that. For any compound to be made, there has to be a reaction between two atoms. So here I have an example of NaF. Now try to see if you know what compound that is. So this would be sodium fluoride. Whenever you see a compound, the first thing that you need to know, I can just look at this and say, yeah, this is an ionic bond. There's two types of bonds, there's ionic and covalent. There is a huge trick for you to know if something is ionic or covalent. I'm going to tell you that now. First, you need to know that before you know redox. So if you go to your log tables, you'll be able to see your periodic table. That's the first thing that you need to know bonding. Alright, so please ignore the little cursor that you have there. It's just screenshotted, sorry. So for ionic, my chemistry teacher gave me this. So that's what you call 1 and 7, 1 and 6, 2 and 7, 2 and 6. Now, what does that even mean? It basically means anything from the first row to the seventh one. So 1, 2, 3, 4, 5, 6, 7. Okay? So 1 and 7, 1 and 6, 2 and 7, 2 and 6. Now I could have drawn that a bit better. Okay, maybe better, maybe worse. So what basically means that it's anything from this column, the first one to the seventh, is going to be ionic. First to sixth is ionic. 2 and 7, 2 and 6. And another trick is that anything with hydrogen, any compound with hydrogen at all, would be always, always, always covalent. Alright, so the whole point of chemical bonding is to transfer electrons, as I said before. These two rows are always the nice ones. They give. They just want to give away their electron that they have. And these guys, this one, 6 and 7, always wants to take. Along with these ones as well, it's alright. But these ones to take, these are the greedy ones. As an example, I have lithium. lithium comes from the first column. Sorry if I called it row before. First column. And it has an atomic number of 3, which basically means it has 3 electrons. So in any atom, there's always two electrons in the first one, and then potentially you should have 8 at the end. So this one doesn't have 8, it's just 1. So that makes lithium extremely reactive. It just really, really wants to get rid of this one electron and just become stable. The whole idea of all atoms is to be stable. They want a peaceful life. So the electron configuration, the way that every single electron is in a particular atom, is what we call this big fancy word, electron configuration. So if anybody asked you to write the electron configuration of lithium, that would be 2 and 1. Lithium basically wants to become helium. Now, if you don't understand that, all atoms wants to copy noble gases. Now, this last row, or column, sorry, is known as column number 8, or 0, because they did not react. Their outer shell is full. It's always 8. Now, why is it 8? Sorry if you already know these things, you can skip over. This is what we call the octet rule. So according to the octet rule, the atom will either gain or lose electrons to become stable. So in this case, lithium, it would be so much easier for lithium to just get rid of this one little electron at the end and just become a nice stable lithium ion, rather than to gain 7 electrons, because that would take a lot of energy and effort. They're just like human beings, they just want to be lazy and get over with. Now, at the same time, if you look at any of these guys, the taking ones, I'll draw oxygen. Alright, so this is oxygen. Oxygen has an atomic number of 8. So that means it has 8 electrons. Now, I've drawn the electrons here, 2 on the first one and 6 on the outer one. Now, oxygen is lazy. It's not going to give its 6 electrons away to just get the or to become stable. So it's just so much easier for it to gain 2 electrons. So as you guys saw, lithium has 1 electron on the outer shell to give away. So that's why it's in the first column. Any of these guys will have 2 electrons to give away, while these ones, group 6, want 2 electrons, and these ones want 1 electron. So it's very ideal if 1 and 7 join, and 1 and 6, yeah, sure, you just need 2 of the ones, and 2 and 7 and 2 and 6. I may have to make another video, but this is so important to understand first. Before I went off in a huge tangent, which was quite needed, come back to NaF, sodium fluoride. So this is how the atoms look for Na and fluorine. So as you can see, there's 1 electron here in Na, and there's how many? Around 7 electrons on the outer shell of fluorine. So it's so much easier if sodium just decides, yep, I'll be the nice one, and I'll give you my electron, and fluorine takes it. Now, both of them are happy because there's 8 electrons on the outer shell of fluorine, and there's none on the outer shell of Na. So this outer shell can go away for sodium, and sodium is happy because it's stable now, and fluorine is happy because it's stable now. Now you cannot call these atoms anymore because the original atom had 1 electron for sodium, but that electron is in fluorine right now, so we call this an ion, both of them actually. This is a sodium ion and a fluorine ion. So ions are any type of atom that has a charge. Any atom that has a charge. Now, all atoms are neutral in the beginning. They don't have any charge because remember the neutron and the proton is +1, electron is -1, and neutrons don't have any charge. Say that they are all so perfectly balanced that they can, well, exist as an atom. So these ions, they have a charge. Now, what charge, you may wonder? Na has a plus charge, while fluorine has a minus charge. See, opposites attract in chemistry. So, Na plus, F minus, Na plus is actually plus 1, and F minus is minus 1. So plus and minus, they cancel, and it's a 0. So that's how NaF can just exist normally without being, reactive as such. It might be reactive, but for anything to exist, it needs to be 0. So any compound is 0. 0 in charge. Now, all these 10 minutes, you might be wondering, oh my gosh, I was here for redox, not for bonding. Well, I'm coming to that. Remember oil rig. Oxidation is loss, and reduction is gain of electrons. Oil rig. So if I go back to my example here, if this will let me, sodium decided to give away its electrons. I know it has a positive charge. In chemistry, it's always the opposite. If it gives away, it's a plus. If it takes, it's a minus. Okay? So just imagine the atoms being nice ones and greedy ones. You can just give plus for nice and greedy for minus. All right, so that's a good way to remember. Don't get confused between maths and chemistry. All right, so since sodium decided to give away its electrons, we call sodium to be oxidized. This fluoride ion, fluorine, decided to take away sodium's electron and become stable himself, and because of that, we call fluorine to be reduced. So that is redox in short. Now we know sodium is oxidized, and sodium has been so nice to give its electron to fluorine, so we need to give sodium a nice name. And that name scientists gives is a reducing agent. It's only because of sodium's electron fluorine is living happy, and it has a reduced ability. So sodium is a reducing agent. So if any of the atoms are being oxidized, they're automatically known as a reducing agent. Now you can just guess what you call fluorine. Now fluorine was a mean one. It's only because of fluorine, our poor oxygen, it's only because of fluorine, our sodium actually had to become oxidized. So because of that, it's called an oxidizing agent. Now anyway, after all their fights and compromises, Na and F has become this friends, I suppose, and their camaraderie is known as NaF, sodium fluoride. Please don't get confused between the oxidation and reduction states and agents. Now, if a question asks you out of NaF, which one is oxidized and which one is reduced, obviously you would answer Na for oxidation and F for reduction. Now, if it asked you for agents, which one is the oxidation agent, you would automatically know anything that is reduced is automatically known as an oxidizing agent. So you would pick F and vice versa. Anyway, so that's the general gist of reduction and oxidation redox. So be nice to everybody, just like these two compounds were. They decide to compromise. So share this video if you found this helpful at all, and like, share, and subscribe if you've liked this. And do let me know if there's any suggestions. So thank you so much for listening. Your results day will come soon as well, just like mine did. And I do hope you have the very best of the years ahead. And yeah, I know some of you are going back to school now. It's September, so, or going to be September. Wow, I'm a bit ahead. So God bless you all, and thank you so much. Be patient with me. I will make another video on redox numbers. That's slightly different, and I will continue on with the titration playlist. So thank you so much for watching, and I'll see you with the next video. Bye.